Okay, so we are going to go through Mark and Sweep garbage collection. Um, Essentially, the idea behind Mark and Sweep. Well, there's essentially three ways that you can do garbage collection, right? And the simplest way is you just have a heap and you'll create a bunch of shit on it. And every time, this is every new object we keep creating, we keep creating, we keep creating. And then boom, there comes a point in our code on line X where we say A equals new object B. And we try to put it in the heap, but then there's no space. So what do? Well, you're gonna go in and you're gonna say, okay, so this is our stack, and in our stack there's references to these objects. Everything that's unreferenced is no longer used. And so you're gonna go in and you're gonna mark all of the objects that you have as useful, that have references as useful. And then once you do that, you're gonna traverse all of your memory space, and everything that's marked you're gonna keep, and everything that's unmarked you are going to bro. Okay, and everything that's unmarked you are just going to get rid of. And then once you've done that, mark and sweep, you can continue your program, and now you can create a new object, and so on and so forth. And you keep going. And so you keep going on and on and on. You fill up your heap, and then once your heap's full, you go through the stack, you mark everything that you want, you delete everything you don't want, and this keeps going on and on and on for the lifetime of the program. Okay, so that's mark and sweep. And then there's other ones, but there's basically the other one is, you just split the heap into two, and you can fill everything up here, and then once you do, you transfer all of the marked objects to the other side, and you clear this one. Then you fill everything here, and then once you do that, and it's full, you transfer all of the marked objects to the other side and keep going. Basically in a ping pong kind of way, which is, not for the sake of this. And the third one is generational, but we'll discuss that later. Okay, so the keyture is showing the physical placement objects in our heap. In our previous object diagrams, we're not concerned with the physical placement, but here we care about physical placement. An exam question will typically ask you for just one time point. Here you're provided with illustration points for studying purposes. Alright, so let's look here and let's see what we're given. We have a public class, yap. Maybe we can I even work this out? No, it's too much. Alright, I might as well just draw it from scratch. What's the question? X and Y or... Okay, no, let's just go through all of them. Might as well. If you have not VONN, construct an expression, simplify it. Alright, so... Alright, let's just do the template. So it's going to be, here's our PC, here will be our statics, which will always contain const false, const true. Here will be our main stack, which will always at least include args. And here we'll have our heap of a certain size, something, and then we'll always have const exp false and const exp true. And yeah, I think that's all I can have in my template so far. And I'm just gonna select all of this such that, why is this software so buggy? It's not even funny anymore. Okay. Not cool. Not cool. Let's try one more time. copy it. Boom. Alright, so having copied that, we can just continue on pasting it. Okay, so let's say we paste it for ish. Okay, so let's say we paste it for this guy. And then this is going to be painful. Okay. One at a time. One at a time. Draw. Alright. We continue with this guy. So first going to do that, and I'm supposed to go to PC of line C3. So I stop at the beginning of C3. So we're going to say, well, the argument takes a string of args. So it's an array. Right, and then I'm going to say simplified. And simplified is just going to take a simplified visitor. So I have a, somewhere in my program, I have the visitor. No one's pointing to him yet, but I'm saying simplify visitor. Not do it, so it's going to do something. And that do it is going to declare a new not expression. And the not expression's E is going to have a value of a true expression. So I'm going to have to create, well, we said the size of my heap is 8. So now I've got 1, 2, 3, 4, 5, 6. I've got 6 values on my heap so far. And then I'm going to say, okay, so you have to have a not expression with a value of E. And that E, that the not expression is pointing to, is the true expression. Okay, makes sense. That's 8. And then we're saying the simplify visitor is going to simplify this guy. So what's the simplification of not true? What's it going to return? Well, it's going to return false. So then simplified holds false, which means simplified is going to point to false. And then, yeah, that's about it. We're done. Alright, let's go to the next one. Not. We're supposed to go up until PCC2. So we're supposed to go all the way up until here and not beyond that. So we're going to say construct an expression. So again, the heap size here is 16. So much bigger. And I have, how many left? 1, 2, 3, 4. So I have 12 left so far. Then the first argument is obviously args. Args is going to point to an array. So that leaves me with 11. Then I'm going to say original. Original is going to point to a new not expression, of new not expression, of new var expression, x. So the first thing I'm going to do is create var expression, and that's going to be x. And then I'm going to create a not expression, and the E of the not expression is going to point to the var expression x. And then I'm going to create a new not expression with an E that's going to point to this guy. So far I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I've got 11 in the heap, I have 5 left. Right, 11 minus 6 is 5. Okay, and then we're going to say that original is going to point to that new not expression. So original is going to point to that new guy. Right? And that makes sense. That makes sense. Now, how Do the diagrams change if we change line 4 like so? Wait, so let's ignore this guy for now. My guy, my love. Let's ignore this guy for now. Let us focus on this. And let's do PCC3. So what would happen, how would I continue my diagram here if C3 was the case? Which says that we are going to, well, we stopped at C2, now I need to stop at C3. Raw. And so that means I need to execute this line, which says that I need to go to my simplifier. So I did have a simplify visitor somewhere over here. And so that means I have 4 left on my heap, slide 16. And the simplifier says simplify visitor.doIt original. So I'm going to essentially do simplify on the original. So what action am I performing? I'm performing a simplify on not e var x, and I'm performing a simplify on this object that I've been given, and I'm seeing the instance of the simplify, and it says that if the thing that it has been given, if the e of the thing that it has been given is an instance of a not expression, which it is, then what is it going to do? And remember, I have 4 left on my heap. Well, it's going to say that not expression n is equal to not expression e. So it's going to create a pointer n that points to e, the value that e is pointing to. So it's going to create an object on the stack. My god, my man, enough. That points to that not e, right? And then it's going to say, potentially use sure. Yeah, okay, that's good. And then it's going to say child2 is going to traverse n.e. So we're going to go to a pointer called child2, and child2 as a pointer, no, I don't like this anymore. What's child2 going to do? Well, it's going to point to traverse expression n.e. So what's n.e in this case? Well, n.e is var x. So child2 is going to traverse var x. That's child2. So now we're going to call a... So remember what we did. We first began with a call to do simplify on the original, and when we said the simplify on the original, this was the original, we said, oh, is the e instance of the original is the e of that, is the expression an instance of a not expression? And we said yes, actually the instance is, oh shit, I did this wrong, oh fuck. Oh fuck. Fuck. Okay. We'll roll with that. We'll roll with that. We shall roll with that. Oops. Oops. I'm sorry guys. Okay. Okay, let me just... Okay, damage can be reversed. I promise you the damage can be reversed. Okay, we called simplify on this, right? But the understanding that what I should have explained is that the original, right, it points to this guy. Okay, so this is the expression right now. And so the first question is the E, so this is the E, right? Is the E an instance of a not expression? Is the expression an instance of a not expression? The answer is true. So then we're going to say, okay, so N is going to point to E. So we're going to say, all right, so N is going to point to the expression. And then child 2 is going to traverse N dot E. So it's going to traverse N dot E. Okay. So now we're going to begin a new stack of traverse. A new stack. So this was the first stack, traverse 1, and now we're in traverse 2. Where the E that we've been fed, so the E that we've been fed here is this guy. The E that we've been fed here is N dot E, so N is this guy, N dot E is this guy, so we've been fed N dot E is this guy, so traverse E takes this guy, so N is equal to not expression E, so N points to this guy, and then child 2 is going to call traverse N dot E, and the N we have is this guy, so the N dot E is going to be this guy, so we're going to begin a new traverse E, where E is the var expression. We understand from the labs that a traverse on a normal expression simply returns that expression. So we're done with the third call stack. We return to our original one, where we said that child 2 is equal to the result of traverse expression, which in this case is just going to be the normal var x, which has been this guy. So child 2 equals this guy. Then we're going to say result equals new not child 2. So we're going to be creating on our object a not with an E, and that E is going to be child 2, which as we can see is this guy. So we're going to create on var x. So I'm going to go ahead on my stack, which I understand has 4 left, and I'm going to create a not E, and that not E is going to be pointing to var x. So I have 2 left. Okay. And then having done that, the result is new not. Return result dot accept this. So return result dot accept this being the traverse guy, this being the simplifier class, so result dot accept, and then the accept of result is just going to do like result dot simplify, or call the simplifier method on it or something like that. So what does that mean? Well, we said that result is the new guy, so this is the result, and the return is result to accept. Can I simplify a not E that points to a var x? Is there any simplification that I can do here? No, there is none. So result to accept this is just going to return the original expression, not E. Okay. So child 2 of my first original call stack is now going to be child 2 is going to equal to this new not E that we just created. So it's going to be pointing to this new not E that we just created. And if we count the stuff that we have in the stack, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we've got two more things that we could create on the stack. And in that case, what would we do? Child 2 is done. Result is going to be new not expression of child 2. So we're going to create a new not expression of child 2. So we're going to make let me just expand my heap a bit. So we're going to make a new not expression E. We're going to make that point to this guy. It's getting a bit messy. Result's going to be the new not expression of child 2. Now we've done 2, so now we have 0 space left, by the way. Like 0, like literally no space left at all. And we're going to say result's going to be the new not expression of child 2, and then we're going to return result dot accept this. And so what can I do with a not, oh my god, that points to a not, that points to an x? Well, I just return that x, right? So I just return this guy. And who takes that return of the traverse, the original traverse, the first guy that called it, is the simplified. And so simplified on my stack is now going to point to my var expression. So if I did everything right, my heap size should now have const false. If I was to clean this up, right, if I was to rough work, clean this all up, for instance, what would I say? Well, I would say that I have my heap, which is of size 16, it's going to have const false, const true. It's going to have an array and a simplify visitor. It's going to have var expression x, not expression with an e. That e points to that var expression, and then not expression e, and that e is going to point to that not expression. Then it's going to have the results of our simplify class, which created a new not e, and that e points to this guy, and then a new not e, and then that e points to this guy. And then I'm going to have a stack. The stack has args pointing to the array. The stack has original, which we can see from the code, pointing to this guy. And then we see simplified pointing to the result of the not, to the not of the x. And that means that the simplified is going to be pointing to var expression x. And now it's time to ask ourselves, did we do this right? And so if we look here, we'll see we have var, so we have var, not, and then not, original points to the original not, simplified points to the new var. Cool. Now if we were asked to go to C4, which tells us, A, compare simplified with expected, so, no, before this guy, so C4 would be, C4 would start there, so we'd end there, so we'd do our code here. Expected is equal to new var x. And in that scenario, I would say, what would I say? Expected is equal to new var x, right? So in that scenario, I would have to declare in my heap var x and call it a day. And can I do this? No, obviously I cannot do this. The reason why I cannot do this is because vibes. No, it's because my heap size is 16 and I've got 2, 2, 1, 1, 2, 2, 2, 2, 2, which means I have 2, 4, 6, 8, 10, 11, 12, 14, 16. So I've already met all of my heaps. If I want to do a thing here, then I must mark and sweep. I must do a garbage collection. I must make space on my heap. And I have my statics here. My statics being the false and true exp. Remember, we create these once so that we don't have to keep creating them. And then I go and I traverse my stack and I say, what here has pointers? And let me just do this. Okay, solid. Okay, so now we go here and we say, what here has pointers? And so in that case, the things that have pointers, no, ew. Okay, very good. No, my God. Okay. What here has pointers? So we say const false has a pointer, const true has a pointer, array has a pointer, simplify visitor, well, it's simplify visitor is in itself a thing that points to, there exists I don't understand. Simplify visitor at this point in time in our code, technically, it should have a visitor, but just looking at this code, there's nothing that points to simplify visitor, right? Nothing points to our class. And so nothing points to it. So we just say, okay, fine. Nothing points to simplify visitor. A var expression has a simplified pointing to it. Not expression E. Well, it's pointed to by this guy, who's pointed to by original. So we're gonna keep, if we trace this original, we keep this guy, we keep this guy, we keep this guy as well. But these two, no one points to them. So we erase them. So the algorithm is to just erase everything that has no pointers from our stack, or pointers of things that have been pointed to by our stack. Sure? Okay, solid. So now how much space have I created? Well, I have 1, 2, 4, 5, 6, 8, 10, 12, and the 16th I've got space for 4. And I'd say I'm gonna do expression result new, not expression child 2, result to accept this. So I say that I'm going to create a new var expression x. So in that scenario, I'm going to say, var expression to vex, and that's going to be pointed to by my variable expected. So we're going to make a new variable expected, and that's going to point to our expression. So if I've done everything correctly, I should see 2 var x's and 2 nots on my heap. And I see 2 var x's, 2 nots on my heap. Okay, so we understand that this is right. Then, of course, if we bump the heap size up to 18 so that collection isn't necessary, if we did not need to do collection, then in that case you'd have 2 var x's You'd have the two knots from the original, the two knots from your simplified, and the simplified visitor. So you would not have had to collect anything. And then the question asks us, how would the diagrams change if we change line 4 like so, such that it's this? Well, that would be a very simple change. The only thing that would happen is, if you trace through it, that in the original diagram, these two would not be created, since since we would just return n returns original reference, but in the final diagram everything would be the same. And the reason why everything would be the same is that the newly created objects get collected by the garbage collector, and so the end diagram on C4 will look the exact same, because the intermediates that were created, which line 4 prevents from being created, are deleted by the garbage collection by the time we get here. Not my best explanation, but I'll try to do a better job here.